I am Dr.A.Vimala Ebenezer, Professor, Civil, Department of Civil Engineering. Introduction to Waste to Energy Conversion. Waste to energy conversion definition. It is the process of generating energy from waste materials in the form of electricity or heat. It is an important part of sustainable waste management, and the objective is to reduce waste volume, recover energy, minimize landfill dependency. This is a picture showing the recovery of heat, fuel and power from waste materials. And the environmental and economic benefits. Environmental benefits include reducing the landfill usage and methane emissions, increasing the renewable energy generation, and also practicing circular economy. Economic benefits include revenue from energy sales, reduced waste disposal cost and job creation. Challenges in waste to energy conversion. The technical challenges include high initial investment, need for waste segregation, and environmental challenges include emissions of dioxins and furans and various toxic ash disposal. And the social and policy challenges are also there. It includes the public resistance and lack of regulatory frameworks. Types of waste include municipal solid waste, industrial waste, agricultural waste, construction and demolition waste, electronic waste, biomedical waste, radioactive waste. And we will see one by one. Municipal solid waste is gathered from the households, commercial establishments and other institutions. The types include organic waste, inorganic waste and hazardous waste. The examples are given. The characteristics of municipal solid waste are it contains biodegradable components and it has various calorific value and it has mixed proportion. And this is a diagram showing the municipal solid waste. Next is industrial waste. The definition is, it is the waste from industrial processes and various manufacturing processes. The types include chemical waste, mechanical waste and some non-hazardous waste like wood, textile, glass, etc. The characteristics of industrial waste is high variability and it is often hazardous, including heavy metals, etc. And it is some are recyclable. This shows some of the solid waste scraps from industries, and this shows that liquid effluent from industries. Then agricultural waste. Definition of agricultural waste is from farming. It is got from farming, livestock and food processing industries, and also the types include crop residues like straw, leaves, husks, etc. Animal waste and also processing waste of fruits, vegetables, etc. Then characteristics include it is mostly organic, it contains organic matters and it is biodegradable, as well as it contains high moisture content. This diagram shows the agricultural waste. Construction and demolition waste is got from various construction works, renovation, demolition works. It includes concrete, brick, wood, timber, metal components, and the characteristics includes large and bulky, highly recyclable. It is reusable in some construction works. This is a pictorial view of the demolition waste. Electronic waste includes discarded electronic and electrical devices, and the types are the household electronics, computer and communication devices, and industrial electronics. The characteristics are valuable metal contents are there, but there are many hazardous substances and it is complex in recycling. This is a pictorial representation of e-waste. The biomedical waste is from medical and healthcare activities. The types include infectious waste, non-infectious waste and pharmaceutical waste. The characteristics include potentially it is hazardous, contaminative, and also it needs special disposal methods, and it has many regulations for disposal of these waste. Then hazardous waste, it is posing risk to our health and our environment. And the types of hazardous waste is toxic waste, corrosive waste, reactive waste, and it has the characteristic of special handling. It is toxic, not only toxic, it is flammable, and it has also some regulations for disposal of this type of waste. Then radioactive waste, it contains radioactive substances. The types include low level waste and high level waste. The characteristics of radioactive waste is long term containment, and it needs specialized storage, and it has radiation risks. It is stored in containers like this. And the characteristics of waste, some characteristics are the physical, chemical, etc. Physical characteristics include volume, density, moisture content, size and shape. This affects the various processes and the storage, etc. Storage and other processes for energy recovery and disposal. Then the chemical characteristics include especially calorific value, which is the energy recovery potential of the waste through thermal processes, and the reactivity, risk of reactions during disposal, and also the composition. The composition may differ, and it affects the sorting, recycling and contamination. The biological characteristics include biodegradability and toxicity. Degradability includes biodegradable or non-biodegradable. Organic wastes are biodegradable. Plastics, metals, etc. are non-biodegradable. Toxicity is a critical concern because the presence of hazardous substances causes environmental and health risks. So the common toxic materials include heavy metals like batteries, electronics, and which are included in these items, and also asbestos in construction debris, and hazardous chemicals included in paints, solvents, cleaners, etc. Environmental benefits of waste to energy conversion. Then it reduces the landfill usage, it reduces the greenhouse gas emission, and also it gives renewable energy, and also we can depend less on fossil fuels, and it gives resource recovery through sorting, segregation, etc., and also leads to circular economy. It reduces the environmental pollution. Some environmental drawbacks of waste to energy conversion is it has air pollution and some other emissions, and toxic ash is also the residue and byproduct. The energy inefficiency, it requires much energy, and also water consumption is high. Health risk also is carried out through emissions. Economic benefits of waste to energy. It gives revenue from energy generation, and it reduces landfill costs. It creates job and also cost savings from energy recovery, and it leads us to be independent from energy. The waste collection and handling. Introduction to waste collection and handling. It is a process and system to gather, transport and prepare waste for further processes, and it impacts the efficiency of recycling, energy recovery and environmental protection. The key points include it is done as services by the local government and or private companies. The formal systems may be absent in less developed regions. It is essential for sustainable waste management. The municipal solid waste collection. The sources are from household, commercial establishments and institutions. Collection methods include curbside collection, which is weekly or bi-weekly, and bin cart collection systems, which has automated lifting, drop-off centers for bulky and large items. The containers include bins, wheeled bins, bags, carts, etc. This picture shows some of the collection equipments and also collection bins. Industrial waste collection. It is the sources are from manufacturing and production processes from industries. The collection methods include on-site collection through drum skips, roll-off containers, etc., and waste segregation, and also bulk collection in compacted trucks or roll-off bins. The features include separate handling and also the source segregation is very, very important. Construction and demolition waste it is from construction, renovation, demolition site, and the collection methods include roll of containers, compaction and sorting at site. Then site specific storage areas, it includes concrete, wood, metals, plastics, etc. This picture shows that demolition waste. Hazardous waste collection. Hazardous waste include chemicals, solvents, batteries, medical waste, etc. And the collection methods include specialized containers, which is leak proof, drums, scheduled collection based on volume and type, and it determines the frequency of collection. And collection centers and drop-off points. Specialized services are also arranged for large generators like industry, etc. Safety includes preventing leakage and also contamination. So this picture shows the methods of collection of hazardous waste in various containers. Organic waste collection. The organic wastes are produced in form of food scraps, gardens, trimmings and agricultural waste. Collection methods include source separated collection in dedicated bins, green waste bins for composting, digestion, etc. Then commercial organic collection from restaurants, stores, etc. The uses is the organic waste is carried out to composting and also anaerobic digestion. E-waste collection e-waste like phones, computers, etc. The collection methods include collection drives and events which are periodic, and also drop-off points for e-waste at centers, and also retail take-back programs. We can return the old devices. This is a method of e-waste collection, and the goal is proper recycling and also disposal. Waste transfer and transport. Introduction. The waste which are collected from various points should be transported to treatment plant or disposal site. This ensures efficient and environmentally responsible movement. The process includes transfer stations, specialized vehicles, and also route and logistics planning. Waste transfer and transport. These are some of the transport vehicles and transfer station, and also final disposal point, which is the landfill. Waste transfer stations. The function of waste transfer station is to consolidate waste from multiple routes, and it enables the use of larger fuel efficient vehicles. It allows for sorting and processing before disposal. Then the types of transfer stations are open transfer stations and closed transfer stations. Compaction may reduce volume for cost effective transport. Waste transport vehicles include garbage trucks, roll-off trucks, compaction trucks to reduce the volume, tankers and specialized vehicles for hazardous liquid waste, bulk transport vehicles for large quantities. The selection is based on waste type, volume and distance to be travelled. Optimizing waste transfer and transport. The strategies include route optimization and scheduling using software, then using some technologies like GPS, automated systems, and also sustainable transport is done by electric vehicles, alternative fuels, using alternative fuels, the collaborative approaches, that is triple P's, municipal industrial integration. The benefits include lower cost, reduced emissions and improved efficiency. Environmental considerations in transport. So the impacts include air pollution and greenhouse gas emissions and noise and odor. So the mitigation is low emission vehicles, proper sealing of vehicles and optimized routes and loads. The goal include minimize the environmental footprint of carbon. Challenges in waste collection. There are many challenges in waste collection because it needs infrastructure, and also it may contaminate the environment, also reduces the efficiency. And public awareness and participation is very important. Climate and weather conditions also affects the waste collection. It delays the waste collection, and it needs education, investment and also new technology. Challenges in waste transport. During transport also the distance and transportation cost. So it affects the fuel and also time. And waste contamination and spillage, especially from hazardous waste, and also traffic and accessibility in urban areas is a great problem. Environmental impact, that is carbon footprint, it may emit greenhouse gases, carbon dioxide, etc. Then public health and safety, especially for hazardous waste. It affects the public health and the persons carrying the waste. And also mitigation is route optimization, and the containers should be sealed, and also it should be followed by safety standards. Then waste sorting. Waste sorting is separating the waste materials at source or facility. Then the importance is to improve the recycling efficiency. It reduces the landfill waste and also conserves energy, and it is a economic and environmental benefit. Waste segregation, these are some of the types of bins: recyclable waste, kitchen waste, domestic hazardous waste. We can collect in different bins. Types of waste to sort: recyclable materials, organic waste, hazardous waste, general waste. Methods of waste sorting: manual sorting, automated sorting using conveyor belts, air classifiers, magnets, etc. Source separation, that is single, dual or multi-stream recycling. Mixed waste processing processes unsorted waste. This picture shows the manual sorting of various materials from the solid waste. This is one type of sorting using conveyor belt. The waste will be transferred through the conveyor belt, and people standing on both sides of the belt will collect the different materials and collect it in different bins. Challenges in waste sorting: it needs public participation. For that, it also requires education, and in every step there is contamination, and also it reduces the recycling quality. And also cost of infrastructure is very high. Complex waste streams is very difficult to separate some materials. So awareness campaigns and technology adoption is much more dependent. And this is one type of separation of magnetic objects. First is concentric design. Here the magnetic rotor is concentric in position. This is eccentric design. The position is somewhat eccentric. So here the material is fed on the belt which is rotating on a magnetic rotor, and the material fed will be moving along the belt, and there will be a splitter. The ferrous materials will stick to the magnetic rotor. The remaining materials like some weightless materials like aluminium will be thrown away, and it will be thrown farther from the belt, and heavy materials, other heavy products will be falling near the belt. So we can separate these things, magnetic as well as non-ferrous and also non-metallic material, through this process. The benefits of waste segregation. Environmental benefits includes reducing landfill use and contamination. Economically, it generates value from recycles and also reduces management cost. And socially, it promotes awareness and responsibility, and it supports circular economy. And challenges in waste segregation. Here also public awareness and participation, and also contamination from incorrect sorting, then cost of infrastructure and behavioral change. Here we can overcome these by using by the use of education, incentives and monitoring. Then pre-processing of waste. Here this is the pre-processing before disposal or energy recovery. So the purpose is prepare the waste for energy recovery, improve the quality, efficiency and safety, maximize the energy recovery, reduce the contaminants, and also we can enhance the consistency of the feedstock and increased material value. The stages include sorting, shredding, drying, pelletizing, and also some biological and chemical treatment. Pre-processing techniques, sorting and segregation is done by manual and mechanical methods. Shredding and size reduction is done using hammer mills and turbine shredders. Drying and moisture reduction is done in mechanical, solar dryers, rotary dryers. Biological and chemical treatment includes anaerobic digestion, hydrolysis, solvent extraction, etc. Pelletizing and briquetting is done for biomass and uniform fuel production. Challenges in pre-processing. This also requires high equipment and infrastructure cost and also has operational complexity, and it also leads to contamination. Investment solution is investing in technology and also training. Waste to energy technologies. The waste material is the technologies include conversion methods like thermochemical, biochemical and chemical methods. Thermochemical methods include combustion, gasification, pyrolysis. Biochemical methods includes anaerobic digestion, fermentation. Chemical method, esterification. Outputs are heat, power, chemical feedstock, ethanol, biodiesel. Thermal conversion technologies. The thermal conversion technologies include incineration, which is full oxidation combustion at a temperature of 750 to 1100. The byproducts include heat energy, bottom ash, carbon dioxide, water, oxygen, nitrogen, gaseous pollutants. Pyrolysis is carried out in the absence of oxygen at a temperature 300 to 800 degrees C. Byproducts are char, ash, bio-oil, fuel gas, and also methane, carbon dioxide, carbon monoxide, hydrogen, etc. Gasification is controlled oxygen content at a temperature of 550 to 1000 degrees C. The byproduct is syngas, which is a mixture of methane, hydrogen, carbon dioxide, CO and inert gases, and also tar and hydrocarbons. Emerging waste to energy technologies. New technologies include plasma gasification, which is carried out at high temperature. Plasma is produced, and also the byproduct is syngas. Hydrothermal carbonization is conversion of wet biomass using water. High temperature and pressure are involved. It produces hydrochar. Incineration. Overview of incineration. It is a thermal waste treatment process that involves burning waste at high temperature to reduce the volume and convert it into heat energy. Widely, it is used for non-recyclable and hazardous waste, reduces the landfill usage and provides efficient energy recovery. This figure shows the incineration process. The municipal solid waste is fed on the left side, and here in the presence of oxygen is supplied, and with the oxygen content the solid waste is burnt in this incinerator, and the heat is recovered, and also the air pollution, that is the air particles in air are collected through filters. The ash at the bottom is collected here, and the remaining polluted air, that is after filtering the air, it is sent outside through the chimney, and here it shows the power production which can be done using the heat collected from this incinerator. The types of incinerator systems include mass burn incineration, which is feeding without pre-treatment. It is suitable for mixed municipal solid waste. And fluidized bed incineration, it is bed of hot sand like particles. It is effective for high moisture waste which contains high moisture content. Rotary kiln incineration, it is a rotating cylindrical drum. It is used especially for hazardous and medical waste. Environmental aspects of incineration, the benefits are it reduces the 90% volume, and also energy recovery is got, and also it reduces the landfill methane emissions and also safe hazardous waste disposal. Drawbacks include air emissions in the form of particulate matter, nitrogen oxides, and sulfur dioxide, carbon dioxide, and toxic substances, dioxins, furans, and also ash generation, which is difficult for further disposal, which contains high metals and also high energy consumption. Economic aspects of incineration, the benefits include renewable energy. We can get a revenue from the energy produced, and also landfill cost savings, and extended landfill lifespan. Because the size of landfill usage is reduced, the lifespan will be increased. The drawbacks include high capital investment and also operating cost and waste sorting and emission control expenses. And gasification, this is the next process, next thermochemical process, which converts carbonaceous materials into syngas, which contains hydrogen, carbon monoxide, and methane. This occurs at high temperature, oxygen limited environment, cleaner and more efficient than traditional incineration. This figure shows the gasification process. The biomass is fed from the left side, and also steam is given from the bottom. Some quantity of oxygen is also sent to the reactor. So the bubbling bed is there. The syngas will be collected at the top and it will be taken out. The gasification technologies include fixed bed gasifiers, fluidized bed gasifiers, entrained flow gasifiers, and plasma gasification. Environmental aspects of gasification. The benefits include reduced greenhouse gas emission, 90% waste volume is reduced, cleaner emissions because there is no emission, it is carried out in a closed container, there is emissions are reduced, and also fossil fuel dependence is also reduced. But drawbacks includes some pollutant emissions also, high energy consumption, and also the waste water from gas cleaning. Economic aspects of gasification. The benefits include revenue from energy generation, waste disposal savings in the form of job creation, and diversified feedstock use. Drawbacks include high capital investment, operation and maintenance cost, and also market volatility dependence. Pyrolysis, the thermochemical is a thermochemical process which is decomposing the organic materials at 300 to 900 degrees C in the absence of oxygen. This produces solid char, liquid biooil, and syngas. This is used especially for plastics, tires, biomass, and also municipal solid waste. This prevents full combustion for varied energy recovery. Environmental aspects of pyrolysis. Here also 90% waste is reduced, and energy recovery in the form of biooil and syngas, and reduced greenhouse gas emission, and it is safe for hazardous waste. And drawbacks include syngas emissions and toxic byproducts like heavy metals and dioxins, and also it consumes much energy. Plasma gasification is advanced technology using plasma arc at a high temperature of about 3000 to 8000 degrees C. Here the conversion takes place into syngas, metals, and slag. The processes is used for municipal, industrial, and hazardous waste and various biomass. And environmental aspects of plasma gasification. It reduces the landfill use, minimal greenhouse emission, and high energy efficiency. It also produces the slag, which is inert in nature, and also toxic waste treatment is carried out in plasma gasification. Economic aspects of plasma gasification. Energy production. A revenue is got through energy production, and waste solution diversification. High value product is got as the byproduct, and also high capital cost and high energy cost. Feedstock preparation is also expensive. Hydrothermal carbonization. This is a conversion of organic waste to biochar, biogas, and liquids. This is operating at a lower temperature of 180 degrees C to 250 degrees C and high pressure 2 to 5 megapascal, and it is effective for wet high moisture feedstocks. This minimizes the natural coal formation at accelerated rate. Then hydrothermal process and products. The process includes feedstock preparation, high pressure reactor with water, and hydrothermal reactions, product formation, post processing separation. The products are biochar, biogas, aqueous organic liquids like fertilizers and biofuels, and organic residues. The environmental aspects of hydrothermal process, it also reduces the greenhouse gas reduction, reduces the greenhouse gas production, and efficient wet feedstock can be processed through this process, and it reduces the landfill usage, and also it gives valuable byproducts. It is very suitable for wastewater treatment. In economic aspects of hydrothermal process, economic benefits include biochar and products are gives revenue, and also energy recovery and waste disposal savings. Challenges are also there. It also involves high capital and operative cost. It includes energy consumption, feedstock preparation is very complex, and also product quality is variable. Emissions control technologies include flue gas treatment, that is using electrostatic precipitators, fabric filters, scrubbers, etc. and also activated carbon filters are used for controlling these emissions. And gas cleaning systems like syngas contaminant removal is also necessary. And biogas purification is done for hydrogen sulfide removal. Then biological conversion technologies. Biological processes include anaerobic digestion and composting. Anaerobic digestion is microbial decomposition without oxygen. It produces biogas. Composting is a organic waste decomposition. The product is a nutrient-rich compost. Biological conversion technology is a natural process. It decomposes organic waste into valuable products like biogas, and also compost can be got, and also biofertilizers are also can be got as byproduct. And it is environmentally friendly, and it is crucial for sustainable waste management. Composting. Composting is a biological process which breaks down organic waste. It produces nutrient-rich compost, which is also called humus. It uses microorganisms in the presence of oxygen. Recycles includes the food crops, food scraps, yard waste, agricultural waste. These are taken to the composting process. It diverts the organic waste from landfills. So this picture shows the compost on the top. The compost, it is a process carried out on the top picture. The bottom picture shows the compost in a bag, which can be used for crops. It is a very good manure, organic manure. Objectives of composting: it reduces the waste from going to the landfill, and also methane emission. And it is a soil rich. It enriches the soil and improves the soil fertility. It is a sustainable process, and it improves circular economy. It is a chemical fertilizer. It can replace the chemical fertilizer. Types of composting includes aerobic composting, anaerobic composting. Aerobic composting is with oxygen. Anaerobic composting is without supplying any oxygen. Aerobic composting takes place up to 3 to 6 months. It takes 3 to 6 months. Anaerobic composting takes 1 to 2 years. Aerobic composting has less odor. Anaerobic composting has strong odor, and aerobic composting gives high quality compost. Anaerobic composting gives less stable compost. Another one type includes vermicomposting and industrial composting. Both this uses earthworms and it is vermicomposting uses earthworms, and it is nutrient dense compost. It is ideal for homes and gardens. It requires high maintenance, and industrial composting is done in large scale controlled process. High volume can be handled, but the cost is very high. Composting components: carbon nitrogen ratio should be 30:1, moisture 40 to 60%, oxygen, regular aeration is needed. Temperature is 50 to 65 degrees C. Particle size is smaller. If the particle size is smaller, the speed will be high. Composting processing stages: 20 to 40 degrees C is mesophilic phase, which is the initial decomposition. 50 to 65 degrees is the thermophilic stage, which is during the active decomposition where the pathogens are killed. Then after that, cooling and maturation, third process, then where the temperature drops and it is got stabilized. Final stage is the curing stage. This is for final maturation, safe for use. And challenges, benefits of composting. Benefits include waste reduction, improving the soil, it reduces greenhouse gas emission, it saves cost. Challenges include odor issues, time consuming, space is needed for composting, and also contamination risk. Biomethanation. Biomethanation is the other name for anaerobic digestion. It is especially used for degradation of organic matter. It produces biogas, which is a mixture of methane 50 to 70% and carbon dioxide 30 to 50%. It converts waste to renewable energy. The key part of waste to energy system. Biomethanation objectives is energy recovery, waste management, nutrient recycling, as well as greenhouse gas reduction. This picture shows the various steps involved in biomethanation process. First step is hydrolysis, where in the step hydrolysis where the complex organic matters like carbon dioxide, carbohydrates, proteins, fats are reduced to soluble organic molecules that are sugars, amino acids, fatty acids. Then that is called as hydrolysis. Then the next stage is acidogenesis, where the soluble organic molecules are converted to volatile fatty acids. So here it will be smaller organic molecules. Then third stage is acetogenesis, where the volatile fatty acids are converted to acetic acid using the acetogen microorganisms. And in the fourth process, methanogenesis, the acetic acid is converted to methane and carbon dioxide. Then another one process is co-digestion. Co-digestion is nothing but one type of anaerobic digestion where two or more organic wastes are combined together. Example, agricultural waste plus sewage sludge. The advantages of this co-digestion is improved biogas production, better stability. Disadvantages, we have to manage it very carefully, and also it leads to contamination. Factors affecting biomethanation is temperature. Mesophilic temperature is 20 to 40 degrees C. Thermophilic temperature is 45 to 60 degrees C. The pH optimal value is between 6.8 to 7.4, which is very well suited for the anaerobic bacteria. Organic loading rate, which is the amount of feed which is given over time. Retention time and also carbon to nitrogen ratio, which should be 20:1 to 30:1. Biogas composition, it is a mixture of methane 50 to 70%, carbon dioxide 30 to 50%, hydrogen sulfide trace amount, and nitrogen, oxygen are also in the minor quantity. Biomethanation application is for electricity generation, heat production, then compressed natural gas, waste treatment, and also fertilizer, which is the byproduct from the anaerobic digestion. Biomethanation benefits, it is leading to sustainable waste management, renewable energy production, nutrient recycle, and also reduction of greenhouse gas. Challenges, improvement in the biomethylation processes. The process is controlled with the difficulties because the pH value, etc. should be controlled within the limit. Otherwise, the process won't work properly, and also many contamination risks and initial investment cost. The reactor cost will be very, very high, and it requires much place and also many arrangements. Then operation cost is also high. Case study 1, Shenzhen water treatment plant in China. The overview, it is handling 5,000 tons a day for 100 megawatt capacity. It is the process they adapt is incineration, the power gen, and also SCR and scrubbers. The key features include high capacity, community engagement, and also for sustainable development. The results include landfill reduction, renewable energy. It also meets the environmental goals. So this is the diagram of the place in China. And Los Angeles Valley Vista, USA. Here also this is a water treatment plant, 1,000 tons a day for 24 megawatt electricity is produced here. So they are using gasification process, and syngas is produced, and from that electricity is produced. So the key features is diversified waste, stringent emission control is there, and also zero waste goals. The result is landfill diversion, renewable energy, and also community support. This picture shows the water treatment plant. And also Sakai waste treatment plant in Osaka, Japan, 1,000 tons per day. It has high efficiency. They follow the incineration with combined heat and power. The key features include advanced emission control, waste heat recovery, minimal residuals. The results are efficient energy for district heating and reduced landfill use. This is the diagrammatic representation, the site plan of the place.